we're starting trig today. We're going to focus on tangent first, and then we're going to pick up sine and cosine as well. I wanted to show you this. This isn't in your textbook anymore. This was always at the back of geometry books, and because prior to calculators, you had to use a trig table in order to calculate missing sides and angles. And so this would get you to the nearest degrees. And what I want you to kind of understand is that what we have going on here is a bunch of similar triangles. Okay, sine, cosine, and tangent are the ratios between the side lengths of similar triangles. Now, we know that all it takes is two angles to say that triangles are similar, right? Angle-angle similarity. So if a right triangle and one angle, then I know I've got similar triangles. So this is a table of values for if I have a right angle and a 1 degree angle, then the ratio of the sides is listed here in your sine, cosine, and tangent. The words sine, cosine, and tangent just tell you where to look on the triangle so that we can all know. So we learn those words and they tell us these certain things. Look here. And then we're all looking at the same place if we're talking about tangent. So those words, like I said, they're telling you which side to look at. And that's in the video when it talked about SOHCAHTOA. That's to help you remember what that means. Okay, so we're going to start with one that we've already looked at. Now, we have found a missing side length using the Pythagorean theorem. We had to know two sides. We could find a missing side length using the Pythagorean theorem. We've also found missing side lengths using special right triangles, 30, 60, 90, 45, 45, 90. And we memorize those so that we know what the ratios are because they're all the same. Clearly, we're not going to be able to memorize all of these. And so they're in your calculator, but I just kind of want to use this as a little bit of a reference. Okay, so let's look at what we already know. 30, 60, 90, 45, 45, 90. We're just going to use the 30, 60, 90. All right, so if I have a 30, 60, 90 triangle, a 30 degree angle here, and if this side is 1, then how long is that one? 2. And what's this one? Square root of 3. All right, now from the 30 degree angle, 1 is the side that's opposite of 30 degrees. We can all agree on that, right? Yes. All right, the square root of 3 is the side that's adjacent. All right, adjacent to the 30 degree angle. Now, you might be like, well, what about the 2? It's also adjacent, but the 2 only has one job. It's the hypotenuse. The hypotenuse doesn't get to be adjacent. So the opposite and adjacent are only going to be on the sides that form the right angle. The hypotenuse will always stay the hypotenuse. All right, so in the video, we had SOHCAHTOA, right? Now, I write SOHCAHTOA like this. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Now, because the numbers are easy for us to look at and compare, we're going to use sine today for this example, but the rest of the day, we're going to be looking at tangent. Okay, so sine of an angle is opposite over hypotenuse. So sine of the angle 30 degrees is opposite, which is 1, over hypotenuse, which is 2. So sine of 30 is 1/2, right? So I look at my table right here, sine of 30, 0.5. Okay, I've got the zeros on it because they're all done to three decimals. 4 decimals rather, but you know, there it is. Okay, it doesn't matter. So, you know, if I took another 30, 60, 90 triangle, and I know that if I started out with 10 here, that would be 20, and when I divided, I'd still get 1/2. So that's what the table is representing. That's in your calculator so that you don't have to pull it up from a table. You just type the numbers in, and then you're able to solve your problems based on that. All right, so first thing I need you to do is check your calculator and make sure it's in degree mode. All right, so when you turn your calculator on and you're on a calculation page, right in the top corner, you should see DEG. If you don't see DEG on your calculator and you see RAD, you're going to have to change it in the settings.
Where does it say?
You need to be inside a document.
Oh yeah, DEG.
Okay, is everyone's DEG?
Oh yeah.
All right, if it's ever not, you don't know how to change it, you need to check with me. When you are using your own calculator, you need to check because default mode is frequently radians. And so let's say RAD. Some calculators have gradients as well. It might say GRA or GRAD. Okay, but you will absolutely get the problems wrong if you work them in radian mode when they're supposed to be done in degree mode, because we looked at how the radians work yesterday, and you know they're different. We've got pi instead of 180, and so that's going to be quite a bit of a different answer. Okay, we're just going to work one angle on the first two problems because I want to do some labeling, and it's kind of hard to have to relabel everything. Okay, so we want to know tangent, or the tangent ratio of each angle, tangent of x. So from x, this side is the opposite, and this side is the adjacent. Now remember, this is SOHCAHTOA, and because I'm looking at tangent, I'm concerned about opposite and adjacent. Okay, that's all I'm worried about today. So opposite of angle or of the vertex x. So tangent x equals opposite, which is 3, over adjacent, which is 3. So tangent of x is equal to 1. What kind of triangle is this?
90,
45, 45, 90. Okay. So when I look on the table at the 45, 45, 90 at tangent, because the third one over is tangent. There you see it. I have the 1. Okay. And that makes sense, right? Because every time we have a 45, 45, 90, we have two sides that are the same. And it's opposite over adjacent. Those are the two sides that are not the hypotenuse. So they're always going to be 1 when we divide it. Okay. And so that's what's happening. And that's why we have the trig ratios, because the triangles are all similar if they're right triangles, and we know one of the angles. Okay, let's do the next one. So we're just doing G this time. So opposite of angle G is 8, and adjacent to angle G is 16. So tangent of G equals opposite, which is 8, over adjacent, which is 16, or 1/2. Okay. We are going to do both P and Q on the next one, and because we're doing both of them, I'm not going to label them, but I want you to see what's happening with that, so to make sure that we're understanding. All right, so tangent of P equals opposite, which is what? 7. Over adjacent, which is what? 24. So across is opposite and adjacent is 24. All right, now we're looking from the perspective of Q. So tangent of Q is opposite, which is what? 24, over adjacent, which is what? 7. Okay, they will always do that. They're always going to be the reciprocal of each other in a particular triangle like this when we're looking at the angles that are across from each other. There's only 3 numbers, okay? You can't have too much variety. So when you are looking at that, and you don't need to memorize it, but, you know, it's just something, you know, that you should know to be true. All right, now we're going to use those to solve some problems. We're first going to solve for angle measures, and then we're going to solve for side lengths. Now, tangent, cosine, sine, they all have to have an angle with them. You can't just say tangent's equal to something. That's like saying square root's equal to 5. Square root of what? Okay? You have to have an angle inside or next to the sine, cosine, or tangent word. All right, so this is going to be tangent of x. That's what I'm looking for. And I want to look for opposite. So opposite of x is 12. And next to x is 5. Okay, but what I'm looking for is the angle, and I know the ratio. And so with what's happening here is basically I could find out, I could do 12 divided by 5 and get a decimal, and then I could look on the table and compare that value and look up the angle measure. Except this one's not a whole number for the angle measure, and I want to tell my calculator to look it up on the table, on its table. And to do that, you're actually going to say inverse tangent, because you know the side lengths and you want to look for the angle. So the way that that's written is x is equal to inverse tangent, which has a little -1 on it, and then you're going to put the 12 over 5, and we're going to put that in the calculator. All right, so inverse tangent, or all the trig functions are on the trig button, which is left of the 7. And so we want to get inverse tangent, so you're going to go to the one that says tangent to the -1. Left of 7 is trig, and it brings up all the trig functions. Some calculators have separate buttons for sine, cosine, and tangent. This one has them all together. Okay, and then I'm just going to put the 12 divided by 5 in there.
Oh, it's 60.
All right, so 3 decimal rounding, 67 point what?
38.
380.
So the decimal always has to have 3 digits.
Yes. From here on out, 3 decimal rounding. The 0 is important because it shows the degree of accuracy to which we are rounding. If we didn't have the 0 there, it'd look like we just rounded to the 100th place, right? And we're rounding to the 1000th place. Okay, do the next one.
What do you do after
On your calculator,
Yeah.
you have the tangent to the -1, the inverse tangent. You should just be able to press enter.
Can I reduce the fractions?
You can. You're gonna bring me your calculator if it's
Oh, I put it in.
okay. What's opposite? 9. What's adjacent? 12. So tangent of x is equal to opposite, which is 9, over adjacent, which is 12. That means x is equal to the inverse tangent of 9 over 12. Okay, you can reduce that to 3 over 4. Will you get the same answer?
Yeah.
Yes, you better, right? Otherwise, that table's not worth a whole lot. And so I've got 9 divided by 12. All right, what do we get with rounding on that one?
38 or 36.80. 0.
All right, very good. 36.870. All right, we're going to move to number 7. So on number 7, we are looking for a side length. So when we're looking for a side length, we won't be using the inverse tangent. We'll be using the normal tangent.
Wait, so why do you have the equal sign like that?
Because it's an approximation, it's not an exact value. Okay, so across from 55 is x. So x is opposite. And next to 55 is 4. It's adjacent. And labeling is super important. It's not as hard today, but when we add sine and cosine in there on Monday and we have to figure out which one we use when, it's the labeling and the thinking about SOHCAHTOA that's going to tell us. All right, tangent of the angle. Tangent of 55 equals opposite, which is x, over hypotenuse, over adjacent, which is 4. Okay, so we want to know what number we'll fill in there so that we can get that, that proper decimal on 55. that our table shows us. Now, to do that, all we have to do is multiply these two things together. So this is just a proportion. We're doing cross products, and we can just think of that as a 1 underneath there, and then that's 1x, so we don't have to do anything more than that. So to figure out x, we're going to take 4 and multiply by the tangent of the angle, which is 55. So you're just going to type it in your calculator that way. 4 tan 55, enter. So 5.71 what? 3, right? All right, do the next one. I'm going to write it while you're writing it, but just try to do it without looking. All right, so I have tangent of 35 is equal to opposite, which is x, over adjacent, which is 20. So I multiply tangent times tangent of 35 times 20, and that gets me 14.004. All right, we're going to look at number 9. Now, number 9, we are still using tangent, but the location of the variable is different in respect to the angle. And so that's going to make our algebra slightly different. So from the 62, 10 is opposite, and x is adjacent. So tangent of 62 equals opposite, which is 10, over adjacent, which is x. Okay, so when we watched the video, they said,
Switch it.
and that's right, switch it. When the x is down below, x and the angle will switch, you know, okay? So that's what's going to happen every time. But I'm going to show you the math why that's going to happen, because I don't want you to just go, oh, we got to switch it. Well, why do we switch it? Okay, when we multiply the diagonals, we get x times the tangent of 62 is equal to 10, because there'd just be a 1 underneath the tangent of 62, so that'd be 10 times 1 is 10. We still need x by itself, so we would have to divide each side by the tangent of 62. Okay, and so that what happens every time is when x is on the bottom, these two switch places, and we do 10 divided by tangent of 62. And we get 5.317. Okay, so when you're looking for an angle, you use tangent with the little -1, so that's inverse tangent. And when you're looking for a side, you use the regular sine, cosine, or tangent. Okay, so you're going to write that on here. When solving for an angle, use inverse tangent, okay? Whoops, there we go. When solving for a side, use tangent. Okay, now on Monday, we're going to add sine and cosine. So it might be inverse cosine when you're looking for the angle instead of inverse tangent. Okay, so these rules are just for today. You're not always going to use tangent no matter what. You're only going to use tangent on today's, and then after that we're going to have to decide, is it sine, cosine, or tangent.
Okay.
But